Here we're going to talk about the area of a parallelogram and a rhombi, or rhombus if it's just one of them, and how we can calculate those. So here we have a parallelogram. Parallelograms are quadrilaterals. They have 4 sides, and they have 2 sets of parallel lines. Those are the only rules for you to have to call it a parallelogram. So there can be lots of different shapes that are called parallelograms. Like a rectangle is technically a parallelogram, but this shape right here is also a parallelogram, and it's what we're going to be talking about. So you can see that on my bottom I wrote the base. Your base is a line that has a side that has a parallel line across from it. That's another side. So technically either of these could be my base, but I'm choosing to use this one right here because I need to also find my height, and I know that the base times the height makes a right. If you're in my class, you hear me chanting it all the time. Base times height makes a right. The problem is that I don't see any right angles in this shape. This right here is an obtuse angle. This is an acute angle. This is an obtuse. This is an acute. None of them are right angles. So, how do we find our height line? Well, if I told you that this is 5 centimeters and this is 4.5 centimeters, that's still not any information you need. You don't go to the doctor and stand at this crooked angle and say, look, how tall am I? No, you stand straight up and down from the floor, making a right angle with the floor, and I don't see a right angle here. So, the reason that we can use the area formula base times height for a parallelogram as well as a rectangle and a square is because technically a parallelogram takes up the same amount of space that its rectangular counterpart would. Here's why. If you chop off this triangle here and then you moved it and it came over here, this triangle would fit in this space right here. So you've taken it away from over here and you've moved it to the other side of the shape, and now what does that look like? That looks like a rectangle. Okay, so a parallelogram takes up the same amount of space as a rectangle, just like a rhombus would take up the same amount of space as a square. The point of that is that you can draw in the height wherever you'd like. And if you use the area formula base times height for a parallelogram, you are actually going to wind up getting the appropriate area. So long as my height goes from one base to another, I can draw it in wherever inside. I could draw it here, I could draw it here, I could draw it right here. I could not draw it right here. This would be a no-no because it does not go from one parallel base to the other parallel base. This goes from a parallel base to a non-parallel side. So my height has to go from one base to another, and it has to form right angles. This does. If I don't tell you what this height is, then I will tell you the area and you can solve for it. Or I would tell you that this is 7 centimeters, and you'd have to solve for the area. If this is 5 centimeters and this is 7 centimeters, I'd say, hey, here's my area formula. Check. Step 1 is done. Step 2, plug in what I know. My base is 5. My height is 7. 5 times 7 is 35. Add my units. Centimeters times centimeters is centimeters to the power of 2. Because even though you wouldn't get perfect squares out of this, when you cut off this section right here and moved it over here, you would get perfect squares. And also it's okay to have an area that has a fractional or decimal amount of a square as its area. That's still measuring how many of those squares could fit in it. You could fit half of a square. Not in this example, but in others you could. Let's try this one. Your parallelogram does not always need to be, that doesn't look super parallel. Your parallelogram does not always need to be with its base horizontally across the page. This would be my base right here. There's my height line. I would say area equals base times height. I know it's obnoxious to have to write out the area formula every single time, but I really, really need you to get in the habit of doing it because it's so much easier to catch your own mistakes, and it becomes so much more necessary when you get to the more complicated area formulas like triangles and trapezoids. So write out your formula, plug in the information you already know. Your height, or your base is 15, your height is 3, area equals 45 feet squared. And finally, let's say we have a rhombus here. Remember, a rhombus is like a parallelogram. It has two sets of parallel lines. It does not have any 90-degree angles, although that's not a rule for a parallelogram, but it does stop us from calling it like a rectangle or a square or something. So, two sets of parallel lines. A rhombus is more similar to a square because it has 4 congruent or equal side lengths. Not a square because it does not have 90-degree angles. This is obtuse, this is obtuse, this is acute, this is acute. But it does have 4 equal side lengths. So if I tell you that this is 5 meters long, then you know that this side also has to be 5 meters. You could easily find the perimeter of that shape by saying, 5 plus 5 plus 5 plus 5, that would be 20 meters. Notice the perimeter does not have an exponent of 2 because the perimeter is really just measuring around the outside. You're not multiplying meters times meters. If I were to take that purple line and unfold it, it would go in 4 sections of a line. That's not 2 dimensions, that's just one long 5 plus 5 plus 5 plus 5 equals 20. If you didn't have to multiply your meters times something, then it's just going to be 20 meters. Okay. Last example. Let's say we have a parallelogram and I tell you that the area is 50 yards to the power of 2. And I tell you that the height is 4. You don't know what the base is. Area equals base times height. 50, I know. Base, I don't. Height, I do. These two are being multiplied. The opposite of multiplying is dividing. 50 divided by 4. Remember, you don't have to throw it immediately into long division. Fractions represent division too, and you could simplify this. Divide them both by 2. 50 divided by 2 is 25. 4 divided by 2 is 2. Okay, I can see now that this is an odd number, and dividing by 2, I'm going to get a decimal or a fractional answer. But let's see, I know that half of 24 is 12. So half of that 1 extra is going to be a half. 12.5 yards, not yards to the power of 2, just yards, is the length of my base. Ta-da! Area of parallelograms and rhombi.